Hi everyone, my name is Lena. I'm pretty excited you're all here. Thank you for coming. I work as a technical team lead at Luxoft and also do research at the Goma State University. And today I'm going to tell you about the innovative approach how to deal with big data and big computations using Fsharp and MBrace framework. So, Fsharp people, raise your hand, please. Wow. Okay. So why may you want to use MBrace? First, it's fully open source framework written in Fsharp. It offers a simple cloud programming model I'll describe in this talk. And the main purpose is to create all the necessary conditions to make the work with cloud computations as simple as possible. It's also pretty straightforward to set up MBrace clusters. So finally, I'll show you some code and examples, so you'll see the framework and how to use it. Let's start. Okay, I'm assuming that you're familiar with Fsharp syntax. It's pretty easy. And here is a small practical example for you to feel the nature of cloud computations. What this code does is finding the longest web page from the list of given URL addresses. If we go through this code line by line, you'll see the max content length function. Its body is wrapped in the cloud block. And inside we have a set of jobs which are calculating the content length of each web page from the input array. Then we're executing these jobs in parallel in the cloud. And finally, we're returning the maximum value of all the results we got. This example is pretty simple, just for illustration, but in real life, we'll have a much bigger list of input data. So this code looks almost like normal code we usually write, but it does difficult and machine effort-consuming computations faster by doing them in the cloud. And here, all the distribution work is performed in the background. So no matter how difficult or resource-consuming the task is, it is spread across your worker machines behind the scenes in the background. And all the tricky things, like the strategy of how the work is distributed, balancing the pressure between worker nodes, and gathering the results back from the cloud to the client, all these tricky things are happening, are hidden from the user and implemented inside MBrace framework. So, how is it possible? It is because of Fsharp computation expressions feature. And it allows the user, us software engineers, to be concentrated on our main code logic. And MBrace uses this feature to abstract away from handling side effects work by doing some additional work in the background behind the scenes. So like here, if the code is executed somewhere else than on your local machine in the background, it is a side effect. Other examples of side effects are laziness, asynchronicity, some non-predictable, non-deterministic behavior. And generally, when the code is executed in a way that is different from the normal way, behind the scenes in the background, it is a side effect. So MBrace uses this mechanism to perform the distribution. So before diving into all the features and opportunities we have with MBrace framework, it would be interesting to lift the veil of what happens inside it. So remember the cloud block that was wrapping our function. If we look inside the framework, its name is the same as the name of the instance of Cloud Builder class. Usually, Builder class contains methods for dealing with side effects. In our case, we have Cloud Builder class, which contains methods that contain logic for distributing the work across our cloud clusters. Okay. Each method of the Builder class takes operation and continuation and uses them inside the body to perform the distribution. If we look through the workflow, it is like following. When the compiler makes the keyword with an exclamation mark, for example, let with exclamation mark, it triggers the call to bind method. Inside bind, the distribution occurs. And finally, we get the result of deferred execution in the generic wrapper type cloud of T. And when the results are ready for usage, they are unwrapped from the generic cloud of T wrapper type to the concrete type T. Okay. Bind is one interesting thing. Another thing is Cloud Parallel. Cloud Parallel, we use it to pass a set of jobs and expect from it to parallelize the work somehow. So how does it work? How does it make it happen? First, it takes a sequence of computations. Inside it has an instance of runtime, which it got from registered resources of the runtime. And it calls schedule parallel method for all the computations, which is implemented as parallel fork join. And it returns the result of parallel computation by executing them and preserves the exception information by appending the function information entry to the symbolic stack trace of the exception continuation. Okay. So let's save it in our memory that cloud block is a special block where we can write code, and it distributes across the cloud. It uses a set of worker machines to perform the job. If you remember the async computation expressions, it uses threads to perform the parallelism, and MBrace uses your worker nodes. It's very similar. And it operates cloud of T wrapper type. It's the main things to save in your memory. So, MBrace. Let's dive into all the features and opportunities we have with MBrace framework. Okay. How to start? We need a cluster. To have a cluster, you have a lot of options. It all depends on your choice. You may want to create a custom cluster configuration. You may want to use Azure infrastructure as a service for the clustering. Or my favorite and last option is to use Brisk. It's like creating a cluster in one click. Okay, if you decide to create a custom cluster, you need to have a set of machines that are visible on the same network. They should have .NET Framework installed and MBrace runtime, probably necessary firewall exceptions, and correct settings in the MBrace configuration file. If you use Azure and you have Azure subscription, you can create a virtual network and add virtual machines to it, and also set them up as MBrace runtime machines, and set the correct settings in configuration file. And usually, you should have a client to connect. Either you have a custom cluster or Azure or something else. Client should have MBrace runtime as well, and also Fsharp supporting environment like Visual Studio or like Fsharp Interactive, Xamarin, or any other. It's pretty simple. And when you use Brisk, you need first Azure account and sign up on the Brisk engine website. Push the button, create a cluster, and follow the instructions. Instructions are like this. Indicate number of worker machines you want, the location of your cluster, next, 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 you're done. It's like 10 or 15 minutes. Okay, when the cluster is already done, we need to prepare for boot. Using this, we indicate the connection from our client. We use MBrace nodes connect, indicate the either IP addresses or if we use Azure host names. Also, additionally, we can indicate the default store. Currently, MBrace supports 3 storage types. It's File System Store, SQL Server Store, and Azure Store. It's quite a big work in progress in this field to add additional storages. Okay. After we prepare the settings, we need to boot our runtime. Using Brisk, we just copy and paste settings from the configuration page on Brisk website and paste it to the config object in our client. It's pretty simple. So to boot runtime, we just call boot for nodes. This array we created earlier. Using Brisk, we just call runtime handle. Okay, cluster is ready, everything is ready, and we're super excited to know the features we may use. You already know one of them. We use Cloud Parallel. It's a combinator. There are other interesting combinators. For example, the previous combinator, Cloud Parallel, it took the set of jobs and distributed them across worker nodes. Cloud Choice is very similar to Cloud Parallel, but it either takes computations, but the computations should return in type of option, either some or none. So it returns only when at least one function returned some value, or if none of the functions return anything. We can convert our asynchronous functions to cloud workflows using Cloud of Async. It is very useful when you have a lot of functions and want to use it in the cloud. It's really helpful. And other combinators like Cloud Raise, Cloud Catch for raising and catching exceptions, Cloud Dispose for disposing cloud resources, Cloud Ignore for ignoring the results of computations, and other. MBrace is fully open source, so you can just open GitHub and look up what else there is. Okay. So far, I spoke only about cloud computations, but there is also cloud data. How to distribute data entities across the cloud. The most simple way is to use cloud cells. Cloud cells is a way to persist data entities and the underlying data store in a mutable way. So, for example, if we have some local data, we can call cloud cell.new and get an immutable reference to it and use it anytime later. So, I need to mention that cloud cells are cached on each worker node for performance. Okay. Also, if you have a large collection of objects, it would make sense to use cloud vectors. It is a partition data structure. So, for example, you can create a cloud vector from your local array and indicate the number of bytes you want to each chunk to be divided in. Okay. Cloud items. A little bit of background. Here is an async incrementation of some reference value. So we have some value, and we increment it 10,000 times. It is a typical race condition, so the value of the result will vary from time to time. If we try to convert this sample to the cloud workflow, we'll get 0, since it wasn't incremented at all. And that's because each node gets the copy of input data on it, because there should be a specific way to perform cross-machine and cluster-level synchronization. That's why there are cloud items. Cloud items are the way to perform safe and transactional cross-runtime operations. So if we rewrite our sample to use cloud items, we will run cloud item update to perform incrementation and run it in parallel in our cluster. It will work correct. Cloud items are implemented as refs under the hood, and they use interlock compare exchange to update the value. So it's safe, and when you need something to be performed transactionally and atomically, you can use cloud atoms. And MBrace is good in that you can build distributed data structures and implement sharding on the language level. Okay, there are also cloud flows. Cloud flows allow us to perform distributed cloud parallel data flow tasks. There is a special way of operation pipelining. First, you have an input. You have a set of intermediate operations like filtering, ordering, transformations, and a terminal operation like count, sum, to array, or any other. And input data could be different formats, like it could be just simple object, it could be other cloud vectors, cloud channels, cloud files, anything you want. And what it does, if it takes an array, it divides it into parts and sends them to each worker machine and performs the intermediate operations on each part, and then finally executes the terminal operation and returns it. So it's a way to perform efficient distribution on data flows. Okay, cloud files. Cloud files are a pretty exciting way to store data in a binary representation. So let's go straight for example. We have a set of URL addresses where lyrics of songs are stored. And we have a function for downloading. It isn't displayed here. Here you can see the song cloud file function, which takes the lyrics and creates a cloud file for it. So it just finds out the song name as the first line and deletes the cloud file if it is already present, and writes all text of the song to the cloud file. And finally, to push the process in, it runs operation for each cloud file, for each song in parallel, using Cloud Parallel. And if you already have some cloud files, you can easily display them and read them using Cloud File Read All text. When you don't need your files, you can either delete them directly using Cloud File Remove, or delete the entire cloud directory. Okay, cloud channels. When I first heard about MBrace, I was pretty curious how to do reactive things with it. It's like when not all data is available at once, when data come by influxes. So we need to have some cloud computation that will receive some data by influxes and update us with the result when it's available. So here, for example, we have some workflow that will replicate the message, just replicate the message for the sake of simplicity. It takes the receive port and send port. It gets some message, if it is available, using receive.receive, and replicates it random number of times. For this, we need to have a job that sends messages using channel send async, and receiving messages using channel receive async. So if we try to send something, we'll get the results like this. And after our work is done, we shouldn't forget to release the resources to kill our channels, processes, and so on. And for this, we may use the feature of MBrace for disposal of cloud resources. MBrace offers iCloud disposable type, which is very similar to disposable in .NET. And for example, like in Fsharp, we may use using statement to automatically dispose resources, and the same for Fsharp, we may use with exclamation mark to dispose resources with cloud disposable. For example, if we take cloud directory type, it implements iCloud disposable, and it is removed after it isn't required. So yeah. Exception handling, it is really strong feature of MBrace because the state of exceptions is global. It isn't locally stored on any machine. It is traveling around. So for example, here we have the same function and obviously wrong link. And if we try to execute this, we'll get the full stack trace and everything would be working as you're used to. Also, MBrace offers a way to monitor the health of your cluster. For example, we may use runtime show processes to list all the processes with their states, whether they are running, whether they're postponed or killed, or anything else. Show workers, it just prints how many workers you have, what is the current load on their CPUs, and other useful information. Using get logs, you can get all logs, yeah. If you attach client logger, you may use, for example, console logger to get all the logs printed on your console. And other pretty useful things like killing processes, resetting the runtime if there were big changes. Okay, and now I'm going to show you some sample in Visual Studio. Okay, so I have used Brisk to create my cluster. So I'm getting the runtime by using runtime get handle and config. I have settings from my connection string of service bus and connection. Yeah, here is the show workers, show processes, administrative comments to get the results, what is happening in the cluster. The download function, which is async, especially for this conference, just to show that we may convert our async workflows to cloud workflows. Split function to split the lists on 2 equal parts, and the set of just dummy URL addresses with song lyrics. Some restricted words that we're going to filter out. And the most interesting is MapReduce cloud workflow. It is recursive. It takes 4 parameters: map function, reduce function, identity, and input list. It is wrapped inside a cloud block. It uses pattern matching inside to check whether input is empty. If input list is empty, it just returns the identity. If input contains one single element, it applies the map function on this value and returns the result of deferred computation if it is ready. It unwraps it to concrete type T. If the list contains a lot of values, if it is not empty, we're getting the left and the right part of it. Then, this is a tricky part. We have a statement of 2 calls to MapReduce function for the left part and for the right part. This operator is cloud parallel. It's an operator that's shortcut for cloud parallel. So we execute MapReduce for the left part and the right part in parallel. And then, when the results are ready, we just call reduce for them. Here, in our sample, I have a map function that takes the URL address of the song. It converts it to the cloud expression using cloud of async, downloads the lyrics. Then it counts the number of restricted words. Then we are finding out the first line, it is just name of the song, and returning the couple of song name and the restricted word count. In reduce function, we're taking the results from map and gathering them together, and sorting them by count of restricted words and converting them to array. And finally, we're creating the process with MapReduce, passing our map function, our reduce function, and the list of URL addresses. And just we want to execute it. Yeah, it's results. Number of restricted words on each of them. So yeah. We already seen that. If we compare MBrace to Hadoop, for example, this is not mine. I took it from the conference MBrace guys gave some time ago. There are benchmarks they performed on the small clusters and on the large clusters, and they're pretty successful. It is on 2013 year, so now there is a much more up-to-date version of MBrace, and the results can be even better. I didn't done benchmarks, but you can go this link and check it by yourself. Okay, today I told you about the cloud computations and distributing the cloud data across the cluster using Fsharp and MBrace and the functional approach to it. So you learned what is the cloud block, how it works inside, how the code is distributed, and what features you may want to use in MBrace. Also, you already know how to create a cluster, and it's pretty easy. You can try it by yourself. Here is also a list of useful resources. It's linked to MBrace website. Let me open it just. It has just definition of what is it, trainings and support features, and there was a link to, here are developers of MBrace framework. They are very smart and friendly, and you can ask them questions, and of course you can ask me questions about this. If we open this on GitHub, here is a very useful MBrace starter kit. It has a lot of samples. Just go to the Azure directory, hands-on tutorial, and there are a list of very smart samples on, for example, Hello World, Cloud Parallel, everything you want, and very highly loaded tasks. So yeah. That's all. Thank you for coming.
Thank you so much, Alena. We have time for maybe 1 or 2 questions. Does anybody have a question? Yes? Oh, hold on.
I was wondering how you would compare MBrace to like Akka.net for doing big distributed jobs and computations.
Compare Akka.net and MBrace. Actually, I didn't use Akka until this workshop. So I think it would be quite interesting to compare how can we combine or maybe compare them. And it's a research topic. I think so.
One more.
How do you handle the case where one of the asynchronous tasks fails? Is there an easy way to do sort of recovery or restart the task or something like that?
Recovery, you can implement it. The framework is still in development, and so if the process is failed, you get an exception. Or what kind of failure do you mean? You can check the status of your process. For example, it can be postponed or faulted. You can look if it is faulted. You can restart it. Yeah.
Maybe one more? Anybody else? Nope. Okay. Well, thank you so much, Alena.
Thank you very much.